element that we need to place on the periodic table here is chlorine. And chlorine, it says, has 7 valence electrons, so we know that it's going to be in group 7 or column 7. And to figure out which row it will be on, we can just look at the energy level once again. So on the 3rd row down, we'll find the energy level 3 for chlorine. And if we move all the way to the right, we can find the location where chlorine is on the periodic table. Alright, so you can check all of these on the periodic table and see that they are indeed in the correct location. But like I said before, this will also help us to know what the charge of everything should be. So chlorine, because it's in this location, should have a -1 charge because it has 7 valence electrons. Alright, so now we just have to sum up with the different trends that we can see on the periodic table. So the periodic table, the way it's arranged, and the properties of the valence electrons, and how tightly atoms hold on to their electrons based on their number of protons, all of these things can cause us to have several different trends as you move across the periodic table. And the first one we're going to talk about is atomic radius. And this means exactly what it sounds like. It's the distance from the center of the nucleus to the boundary of the surrounding cloud of electrons. So what that means is, if you have your nucleus, and out here you have all your electrons, your atomic radius will be from the center of the nucleus all the way to the edge of the atom, where the outermost electrons are located, or the valence electrons. So we'll see what this trend looks like, but as you can imagine, the bigger the atom is, so the more protons, neutrons, and electrons, the bigger the radius should be, okay? So the size of the atom should be bigger based on how many particles it has. But there's one interesting thing that we're about to see when I move this block. As you move down the periodic table, the atoms are indeed getting larger atomic numbers, so therefore they are bigger atoms. But as you move to the right across the periodic table, the atomic number is increasing, so they're having more particles in the atom. However, the atom gets smaller as you move across to the right on the periodic table. And the reason for this is that the atom holds on tighter to its electrons and pulls them in closer to it, because it's less likely to give them up to become a positive ion as you move to the right. Remember, on the left side we had more positively charged atoms. 10. This side is positively charged atoms when they become ions, and this side is negatively charged. And that's because the left side is easier to take away their electrons, and also it's easier to take them away because the outermost electrons are farther away from the nucleus. That's why the radius is so big. As you move to the right, it's harder to take their outermost electrons away. They're holding them in really close to the nucleus, and that's another reason why the atom is so small. Okay, so instead, those atoms like to gain electrons to become negative. All right, so that's one trend. Okay, so the next box is ionization energy. And this is one of the trends we see on the periodic table. The ionization energy is the amount of energy it takes for an atom to lose one of its electrons. So the amount of energy it takes to take away one of the electrons on the atom. So as you can imagine, since it's easier to remove electrons for the elements on the left side of the periodic table, because those are the ones that become positive, which means they've lost an electron, the amount of energy that it requires is lower. So it does not require as much energy to take those electrons away. So ionization energy then would be lower on the left side of the periodic table. And as we move to the right side, it requires more and more energy to take electrons away. So the ionization energy will increase as we move to the right. So just like it shows here, the arrow is moving to the right, showing that the increasing energy of ionization energy. And also, the bigger the atom, the easier it is to take away its outermost electrons. So as you move up the periodic table, it takes more and more energy to take away those electrons. So the increasing ionization energy is as you move to the right and also as you move upward on the periodic table. Alright, next we have electronegativity. And the thing that you should always know for electronegativity is fluorine, most electronegative element on the periodic table. If you're ever asked any question about electronegativity and fluorine is in that question, know that it is the most electronegative. And what this means is how strongly an atom can pull a pair of electrons towards itself. So if it's in a bond with another atom, it can pull the electrons in the bond more towards the center of itself, away from the other atom that it's sharing them with. Okay, this is electronegativity. And so as we move towards fluorine, that's where electronegativity is going to be the highest. So since fluorine is in the top right, the lowest electronegativity is in the bottom left. And so we see increase as we move to the top right because fluorine is located right here. So that's how the trend for electronegativity, and if you have questions about why that is, we can discuss that. But in general, this will be more important once we move to actual bonds and understanding covalent and ionic bonds. Okay. Next we have electron affinity. And what this term means is that an electron or an atom has a certain affinity for electrons. That's its desire to gain electrons. Its desire to hold on to its electrons and to get another one. Okay? So this is like if you really like say playing basketball, then you would have an affinity for basketball. It's the same thing with atoms. The ones that really like to gain electrons have a high electron affinity. And so the atoms on the right side of the periodic table are going to have a higher electron affinity because normally those become ions that are negative, which means they've gained electrons. And so it should move the same way as ionization energy. It should get higher as you move to the right, and also it should move higher as you move up on the periodic table because the nucleus can have a stronger effect on neighboring electrons if it doesn't have a whole bunch of electrons around it like some of the big atoms have. Okay, so electron affinity increases as you move to the top right. And that is all of our periodic trends. And let me just quickly explain why that's important. If you were to compare some different elements, you should be able to tell me which element has the highest electron affinity out of the elements you're given. You should be able to tell me which one has the lowest electronegativity out of the ones you're given, and so on. You should also be able to use that information to place them in approximate locations on the periodic table, which we're going to be doing in class this week. So that's all we have for today, but make sure if you need to, you go back and watch these again to get all the notes you need, and that's it.